All engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello and welcome to the programme where we bring you the latest breakthroughs in science, technology and medicine. I'm Chris Smith, and in this week's programme, it's a look at the science behind the headlines, including Sir David Attenborough launching his new documentary this week, The Green Planet. It showcases the wonderful world of plants. We have a sneak peek of what awaits us. We'll be updating you on Omicron and what we think the virus has in store for us next. A naked gamer and a tech journalist will join us to look at some of the top games and gadgets that you can look out for in 2022. And 100 years ago this week, the first diabetic was treated with insulin. We'll hear the remarkable story. First, let's kick off with COVID. Now, it's been a pretty turbulent few weeks since the emergence of the Omicron variant that spooked policymakers, the general public and the media.
Let's begin with a full update on the new Omicron variant of coronavirus. The World Health Organization says it would have severe consequences for some parts of the world if it spreads. The WHO says the overall global risk related to the new variant is assessed as very high. Health ministers from the G7 group of rich countries have met and say the global community is faced with the threat of a new, highly transmissible variant of COVID-19, which requires urgent action.
But is it turning out to be the threat that some claimed it would be? And what's likely to happen in the weeks ahead? Well, with me are immunologist Luke O'Neill, he's from Trinity College Dublin, and mathematician and disease modeller Christina Pagel, who's from University College London. Christina, let's start with yourself. What are the numbers looking like at the moment?
Well, they're higher than they've ever been during the pandemic. The kind of official case counts that we're getting every day at the moment aren't telling us that much because there's a lot of changes in testing over Christmas and New Year anyway, plus we know that testing is kind of maxed out at the moment. But the kind of National Infection Survey released its latest numbers today, and they showed that up to the week ending at New Year, 31st of December, 6% of England had COVID, which is like 2-3 times higher than we've ever seen before. And that was 10% in London.
Do we know who that 10% in London, a couple of percent of the population on the whole are? Are they any particular groups in society?
Well, pretty much every age group is higher than it's ever been. It is still concentrated in younger adults and school-aged children. What is quite concerning in the infection survey is that over 2% of over 70s now have COVID, which again is quite high. Now, luckily that group is highly vaccinated, so hopefully it won't lead to new admissions, but cases are certainly going up quite steeply in over 50s now across the country.
Because people were saying, look, this is a mild disease, and if we look at South Africa, there doesn't seem to be the same rate of translation of cases into severe consequences like there have been with other variants hitherto. But could that be just a function of the fact that younger people were getting a lot of these, or were accounting for a lot of these cases initially, and it's later we're going to see it filtering into more older people who might become more unwell? Or are we pretty comfortable it is a mild disease across the age spectrum?
I mean, certainly in South Africa, the average age is 20 years younger than in the UK. So we do have an older and more vulnerable population. Part of it is that Omicron does seem to be intrinsically a bit milder than Delta. It doesn't seem to cause the same kind of lung disease that puts people on a ventilator. But because it's so infectious and it's infecting so many people, it is still causing a big burden in hospitals, although now that burden is more on the ward than in intensive care. So you've kind of got a combination of stress on hospitals from a really big backlog people are trying to treat, loads of new COVID patients coming in, and then also loads of staff being off sick, like 10 to 15% of NHS staff off sick. And that's just creating these big bottlenecks. So that loads of hospitals now are declaring crises, the military is going in to help, ambulance services are taking, hours and hours to get to urgent cases. So we are in quite an overwhelming situation just because of the amount of infection that is around right now.
So it's more a problem of what it's doing to our ability to run services than actually what it's doing to people per se at the moment. Luke, bringing you in here, Luke O'Neill, what are the sort of experiments that scientists are now doing telling us about whether or not this is a more severe illness or not? Do we know yet whether it's just a function of who's getting it, or whether there really is something fundamentally different about the biology of this Omicron variant that means we're weathering this storm better?
We're learning a huge amount, Chris. The amount of immunology going on all over the world about this variant is startling in many ways, and we're learning on a day-by-day basis. It's lab-based. I mean, that means does it translate into the real world is one question. There's a couple of things that we're pretty confident about. One is that it does, as Christina said, it doesn't really affect the lungs so as much as the upper airways. And there's lab-based experiments, including in animals, to support that. The change in the spike protein means it seems less able to latch onto your lungs. And that's good because the lung infection is what causes severe disease. It is able to infect the upper airways massively, as much as 70-fold increase compared to Delta, for example. So something's changed there. If it stays in the upper airways, it's less of a concern for the person who's caught it because it's less likely to become severe, and that's a good thing. That seems to be consistent with the clinical course of this disease with regard to Omicron, and we hope that holds up. The second thing that we're more confident about is the T cell response is holding up. Now, the immune system has two key parts, the B cells that make the antibodies and the T cells. The T cells are still able to recognize parts of Omicron, in other words, parts that haven't changed that much compared to Delta. And T cells are very good at stopping severe disease. Their job, in fact, is to stop severe disease. It's like plan B for the immune system in a way. Plan A is antibodies that can stop you getting infected and limit the spread in your body. If that fails, the T cells kick in and they kill virally infected cells, and therefore the virus can't really grow very much. And the evidence at the moment, at least, suggests that T cells can still fight Omicron. That gives us hope that the clinical data, which says it's less severe, may be true, basically, because we have these two aspects of the virus then that our bodies can handle, if you will.
But we're waiting really to gather that real world data, aren't we? In which we're doing in real time. One question that's surfacing quite a bit is people are saying, well, if the vaccines haven't changed to reflect the fact that we have this new Omicron variant, why do they work at all? And why would a third dose work better than the two you've already had? What's the immunology of that?
Previous vaccines, you learn as you go along. Some vaccines are 4 shots. The tetanus vaccine, you need 4 shots. That was discovered empirically by just testing it, It's now clear this is a 3-shot vaccine, really. Why would that be? The immune system is a fascination. Every time you challenge it, it does even better. It's almost like it's exponentially better every time. You train the troops, then train them again, and a third time. The third time really trains them.
Have you escaped infection so far, Luke?
No, I caught COVID, Chris, about 4 weeks ago, actually. I was a close contact with someone. 4 days later, I tested positive. Now, luckily, it was very mild, Chris. I had 3 days, bit of a sniffle, bit of a cough. Ironically, I was tested positive the day after I got my booster, to show you. And I said, isn't that sod's law? It's no surprise you get infected after you're vaccinated because the vaccines don't really work in the nose. It's very hard to get the immune system up into what's called the mucosa. So it's no surprise you might pick up a bit and test positive. The beauty is, if it goes to your lungs, the immune system kills it. And that's why vaccination is so important.
Just to finish, Christina, there's been a bit of negative press around the whole maths modelling and prediction side of what's going on at the moment with the pandemic. Now, it was Niels Bohr, I think, who was the forefather of quantum mechanics, who said prediction is very difficult, especially when it concerns the future. This is no different, is it? But how did they manage to get it so wide of the mark? Because, I mean, there were numbers that were being produced, such as 6,000 deaths a day, 10,000 people going into hospital every day. We're a long way from that at the moment. Is it just that we haven't got there yet? Or was this a worst-case scenario on steroids, as one minister put it?
I don't think they have really got it wrong. I mean, what you do with modelling is you take the best available information at the time, you put it in and you see what would happen under different scenarios. Now, the best available information at the time, which was early December, was that Omicron had the same kind of severity as Delta. And under that scenario, when you have the number of infections we've got now, which is 3 or 4 times, and you know that it can evade the vaccines, then you're in a situation where that could have been a possibility. Now, it then turned out that actually, yes, it is a little bit milder. And then they updated their models, the deaths came down. And what they said is, okay, well, we might still have really high hospitalizations. And so far, hospital admissions are running within their range. In fact, if anything, slightly higher than what was predicted by the SAGE models. I think what people forget is that what SAGE does is it says, okay, under this scenario, this is what we think might happen. And then if the government says, well, actually, I don't want that scenario, so I'll change what I'm going to do, that scenario never happens and the predictions don't come true. And that's kind of what happened, certainly in the first wave and also last December. So I think people kind of have to remember why you're modeling. You're modeling to inform policy. And if policy changes, then what you modeled won't happen. It doesn't mean the model was wrong. It means it's done its job in informing policy.
Christina, thank you very much. That's Christina Pagel, and also with us, Luke O'Neill. Thanks to both of them. And Luke's book, which is called Keep Calm and Trust the Science, an extraordinary year in the life of an immunologist. And he can write the sequel now, What It's Like When an Immunologist Gets COVID. It's out now.
From baffling British weather
The sideways spines of the vertebrae coming off here.
to looking at a cheetah from the inside out, games making their way to the clinic, and what to eat in your garden. The Naked Scientists In Short podcasts bring you a top-up of short, compelling science stories. Listen and download for free at nakedscientist.com/short or subscribe to Naked Specials wherever you get your podcasts.
Coming up, the computer games that topped the charts in 2021. Naked gamer Chris Barrow is waiting in the wings, armed with his joystick at the ready to tell us all about it. Also, we'll get the inside track on David Attenborough's new TV series that introduces us to the plants that make life on Earth possible. And we'll also hear about the launch of the most powerful telescope that's ever been built. But what will it reveal to us? First, though, let's talk tech and find out what were the top tech trends in 2021 and what is on the way in 2022. Zoe Kleinman is the BBC's technology editor, and I hope she's going to be able to tell me, Zoe, what has tickled your tech fancy in 2021?
I asked a few people about this, actually, what has been their top gadget of 2021? And the answer that kept coming back was Apple. It's no surprise, is it, that they've just been named a $3 trillion company, because we had the iPhone 13 that lots of people were waiting for. We've had the AirTags that have been a big hit. You know, Apple really does still have the golden touch when it comes to launching products. That said, let's not forget that we've had this crazy backdrop of a global shortage of chips. It's causing big supply problems. And so I suspect a lot more people would have got their hands on a lot more gadgets if there'd been more chips to have made them with in the first place.
Well, actually, I was a victim because I tried to go and buy a Raspberry Pi for something because I wanted to build a project, and I was shocked to see sold out across the board. And further investigation shows, yes, that they're a victim also of the global chip shortage.
Yeah, it's in all sorts of things, isn't it? And you know what really struck me is how many chips these devices need, especially cars. There's a big problem with the car industry at the moment. You know, it turns out cars are sort of more computer than vehicle these days. They have dozens and dozens of these chips, and they're just not anywhere to be found. And the other problem is you can't just, you know, set up a chip making factory overnight. It takes 2 years. So while all over the world, countries are sort of scrambling to get production up to speed, it's taking ages. And, you know, they're saying that possibly even towards the end of 2022, we'll still be playing catch up here.
One other big story which came in the latter part of the year was Facebook, this rebranding of the entity as Meta, and Mark Zuckerberg setting out his vision for what he dubs the Metaverse. So what actually has he got in mind for the non-inclined towards what Facebook do?
The metaverse is one of these things that you're going to hear loads about in 2022, but it doesn't exist. It's not going to exist in 2022. It's going to take years to build. So it's going to be one of those things we're going to talk about a lot, and you're going to sit there and go, okay, well, when can I actually see it? And the answer is possibly 5, possibly 10 years time it will be ready. It's a kind of think about it as a sort of really extreme virtual reality where you are living inside the web, if you like. You're navigating various worlds using an avatar. You're not looking at a screen. You're actually part of the action. It's what some of the tech giants are seeing as the next evolution, if you like, of the web. You know, the first one was kind of us looking at very static information. The second one has been us, you know, using platforms to share our content. And the third one is, instead of looking at our content, actually being in it. It sounds crazy. It sounds very ambitious. I mean, Facebook, you know, is very influential, has thrown a lot of money at this, has rebranded itself accordingly. So Zuckerberg obviously thinks this is the future. Will consumers go? Will they vote with their feet? Well, I think it'll be interesting to watch VR. Is this finally the big year of VR? We've seen virtual reality grow in popularity over the years, but it's never been the sort of ubiquitous big thing that we thought it was going to be. Could this be the year? I hate to bring up Apple again, but they are rumored to be bringing out a VR headset in 2022. Apple, as we've said, just tends to do things well. Could it be that product becomes the breakthrough product that gets a lot more people on board?
I was watching over New Year a rerun of Johnny English when he dons a virtual reality headset and accidentally ends up in the street and then beats up a cafe owner, pushes a lady out into the street and another bloke off a bus. Do we really want this? I'm not sure the idea of sort of sticking a modified ski mask over my face and pretending I'm in a meeting with my colleagues is going to be any nicer than just going and meeting my colleagues. I mean, why do we want this?
Yeah, I agree with you. I think the hardware, the actual headset has really held it back. It's clunky, it's uncomfortable. Lots of people get nausea, get sickness. I get sickness in VR after a while. I can't do it for that long before I start to feel quite queasy, which is embarrassing, but never mind. And I think, in a way, you're right. I don't think it will replace meeting people face to face. But if we've learned anything in the last 2 years, it's that actually, sometimes we have to meet online, and it's easier to meet online. And it's better for the planet, I suppose, to meet online than to be jetting all over the world doing it. And it's not long before you get that sort of Zoom fatigue, don't you? And you start to think, you know what? I like you, Chris. Do you play golf? Why don't we go for a virtual round of golf while we're having this chat? What would that be more interesting? Would that be more fun? Would it help us to connect better? Yes, possibly it would.
Well, we've moved the conversation on to the question of gaming and so on. There was a new game demo that was Matrix Awakens. It's by Unreal Engine 5 that's come out. It's basically the original Matrix film remade, but all CGI. Absolutely amazing to some people's minds. Someone we got to play it said this about it.
Unreal. It's supposed to be unreal. Oh, here come the agents. Bit of slow-mo going on. It does look very, very good.
And bottom line is that they were creating all of the footage in a computer. And so it's not film anymore. It's basically computer generated, but good enough to fool Alex Rhodes, who is your correspondent. You asked to review that for you, Chris Barrow from the Naked Gaming Podcast is with us. He obviously liked it. He was obviously quite impressed.
Yeah, it's one of those tech demos which gives you a flavour of what the future of gaming could be. What was amazing about this particular demo is that it was like you were watching the Matrix film, the classic Matrix footage, and then you press a button and you'd see all the underlying graphics that go into build all the models of the characters and the buildings and things like that. And you realise that actually this video game sort of simulation of the film, it's like another kind of Matrix. And then the game demo type thing drops you into the game, and then you can actually walk around the city, which you've come to know and love from the film. So it's unbelievable, the scope and the scale of what they can do. And obviously, it's only a tech demo, it's not a proper game, but it gives you an idea that actually, let's say you've watched a new Marvel film, the new Spider-Man film, well, maybe they could just scan that into the the Unreal Engine 5, and you could be running around as Spider-Man using those buildings to swing around. So it's an amazing tech demo, and yeah, Alex was quite impressed, as I think you heard there.
The thing is that the games industry is actually, as a value prospect and value proposition, is actually much bigger than Hollywood in terms of its turnover, the amount of money that flows through it. And games have gone from very, very basic 20, 30 years ago to things, as you're hinting at, that could rival Hollywood. Now, are we at risk of losing the message in the medium? Because you're employing armies of artists, you're employing huge, great computing power to make something that looks all glittery and sparkly. Are we actually losing something, the essence of why people wanted to play games?
Yeah, and I think that's a very good point, that there are certain genres and styles of game, and some people like Lee Milner, who co-presents the podcast, she hates games that are like films because she thinks that it is losing the essence of what gaming is, which is to, have control, to jump around, to lose yourself, to, collect coins. She loves those kind of old school games. Whereas like this Matrix game and like some of the huge releases from 2021, Ratchet and Clank, Rift Apart, it feels like you're playing a Pixar film. It feels like you're running around in that kind of incredible world, but for some people it's just too much, and I dread to think what it's like to be a games developer starting up in this day and age, because how on earth can you have the budget to create the sort of games, the AAA games that are running on the PlayStation 5, the Xbox, that PCs now that are so incredible? You just can't do it. So you see startup companies are going back to creating old school games, 2D side-scrolling platforming games, and once they've done that, they then reinvest their money into their next big release. So I totally agree that there is certainly a danger of losing what gaming is compared to watching a film, but some people love that. And you know what, if someone really wants to essentially watch a film but press a couple of buttons here and there, there's a market for that as well, and it can be very relaxing to do that.
Zoe, is the huge demand that this is putting on computing power, is gaming driving the industry, or is the industry and what we can do enabling gaming? Do we know, or is it both?
That's a great question. I suspect it's a bit of both. I mean, I think there's nothing more frustrating for a gamer than their kit not being up to scratch, whether that's your broadband connection being too slow to download the game you want, or Microsoft has an amazing game where you're basically a pilot and you're flying around the world. The graphics are beautiful, it's stunning, but your average computer won't be able to manage it, so you need sort of proper kit to be able to do it, and I think that does cause some frustration. And the Unreal Engine is just a phenomenal tool that's been developed by Epic, who are probably best known for the game Fortnite, but the Unreal Engine is kind of a really interesting part of their business, and this idea of sort of being able to virtually create an entire world so realistically.
So what will you be, to finish, Chris, playing in 2022, your eagerly awaited release?
Well, you talked about the semiconductor chip shortage. I was trying to buy a VR headset, but I can't get hold of one yet because they're just not in stock anywhere. So I'm looking forward to Zelda Breath of the Wild 2. I think that's probably a lot of people's most anticipated game. If you really like the Zelda series, you're going to be really looking forward to that on the Nintendo Switch. The first one was just incredible. And there's a new console coming, actually, which is super interesting, just to quickly mention, called the Steam Deck. And if you've always wanted to play computer games, but you can't afford a hugely expensive computer like myself, if you just don't have space, this Steam Deck console will actually play all of those Steam games, which are traditionally based on a computer. So we're looking forward to the release of that early on this year, to just give it a go, because it's super interesting how powerful handheld consoles can now be.
What are you talking about? Can't afford it, Chris. It's all on the Naked Gaming budget, isn't it?
Yeah.
Thank you for joining us, tech journalist Zoe Kleiman and also Naked Gaming's Chris Barrow. Now, on Christmas Day, you may well have been tucking into your turkey dinners, but in South America, space scientists had some much bigger fish to fry.
5, 4, 3, 2, unité.
And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Now, that was NASA's coverage of the launch of its Ariane 5 rocket that was carrying the $10 billion James Webb Space Telescope, which we are told will enable us to see the universe like never before. Well, here to tell us hopefully what is in store for us is the University of Cambridge's public astronomer and author, Matt Bothwell. So, Matt, was it turkey for you or telescope? Were you watching it?
I was watching. It was all about the telescope for me. I was glued to the TV, and everyone that was passing by, I was, frantically showing them the exciting things happening. It was amazing. Did you watch it?
I was enjoying my turkey too much, but it did get off the ground.
It did, and it got off the ground absolutely beautifully. I think one thing that me, along with all the other astronomers in the world, were hoping for was a really successful launch, because the more fuel remaining for James Webb, the longer its potential lifespan. And it turned out that the launch went so perfectly, it's going to massively exceed its 10-year lifespan. So we're going to get a very long time of exploring the universe with James Webb.
How does it work, and what's it actually going to do?
So the telescope is an infrared telescope, so it gets compared to the Hubble Space Telescope quite a lot. I think a better comparison is the Spitzer Space Telescope, which is a bit less well known, but is an infrared telescope that's going to be taking photos of the universe in these long wavelengths of light. The difference between James Webb and Hubble, of course, is that James Webb is much further away, while Hubble is orbiting around the Earth. James Webb is going to be beyond the moon, about 1.5 million kilometers away, where it's nice and cold and dark to get this very good infrared view of the universe. And it's going to spend 10 years or more exploring all kinds of things, from the atmospheres of exoplanets to the first stars that switched on in the universe.
And there's no risk of it being broken like its predecessor, the Hubble, was launched and then unfortunately was discovered to have some flaws that required a spacewalk to fix. We don't think that's going to happen here then.
Well, hopefully that won't happen. I wish there was no risk of it being broken. Unfortunately, James Webb has an awful lot of potential failure points that might end up with a non-working telescope. And the problem is, of course, that it's being so far away and not orbiting around the Earth, there's no chance to fix it. Luckily, at the time of recording, about 75% of all the risk involved in James Webb's deployment has been passed with flying colours. So we are well on the way to a perfectly working telescope, but we're not out of the woods just yet.
And speaking of working, when are we going to start to see data come back, images that we can analyse?
It's going to be a little while, to be honest. So James Webb is going to spend the next few months cooling down to operating temperature, and then hopefully by spring or summer 2022, we'll start to get some nice pretty pictures back.
And what are the big questions they'll be asking with it?
So James Webb has a few different science goals. One of them is to explore the atmospheres of exoplanets and look for various things, including what we call biomarkers, signatures for potential organic processes going on in these exoplanets. Another one, which is very near and dear to my heart, it's my own research area, is the study of very, very ancient galaxies early in the universe. James Webb is designed to see some of the first stars that ever lit up the dark in the cosmos, and it's something we've never seen before. So all kinds of things that are just completely on the cutting edge. I mean, it's all incredibly exciting.
Well, let's see. When we get you back this time next year, you can tell us what has been seen so far. It's a pleasure to have you on the programme. Thank you very much, Matt Bothwell, Cambridge University's public astronomer.
Much has changed for business owners, managers, and staff recently. But with over 30 years' experience in telecommunications, award-winning independent company Spitfire have the expertise to make sure you stay ahead and can keep on innovating. Whether it's connectivity, MPLS networks, firewalls, or phone systems, Spitfire can help. To find out more, go to spitfire.co.uk. That's spitfire.co.uk. Spitfire, telecoms and IP engineering solutions for business since 1988.
Still to come, new research this week has found the animal where the superbug MRSA is alleged to have originated. The results of that study might make you prick up your ears, and there's a clue. But before that, to the life-saving medicine, which is insulin. Now, for people who live with type 1 diabetes, insulin is a lifeline because people with this condition can't make any of the crucial insulin hormone themselves. Insulin tells our cells to pick up the sugar glucose in the bloodstream. Now, if this doesn't happen, our cells run out of energy and levels of sugar in the bloodstream climb dangerously. Long term, this can damage blood vessels, nerves, our kidneys, and also our eyes. Historically, type 1 diabetes was a fatal condition until this week, a century ago, doctors began injecting the hormone and saving lives. The story of diabetes can actually be traced back much further than a century ago, though, in fact to 1776, and a certain Dr. Matthew Dobson, who boiled the urine from someone with diabetes and noticed something peculiar.
There remained, after the evaporation, a white cake, and this cake was granulated, broke easily between the fingers. It smelled like brown sugar. Neither could it, by taste, be distinguished from sugar, except that the sweetness left a slight sense of coolness on the palate.
Luckily, not something that we do in medical school these days. But with us now is Kirsten Hall, who's written the book called Insulin, the Crooked Timber, which documents the history of diabetes. Bit of an unconventional technique these days, Kirsten. Take us back to 100 years or so ago, though, and tell us a bit more about how diabetes was actually discovered and what insulin's role was found to be.
Well, Happy New Year, Chris. Thanks very much for having me on the programme. Actually, the oldest reference to diabetes is actually on an ancient Egyptian scroll from about 3,000 years ago. I think the Ebers Papyrus talks about a medicine to drive away the making of too much urine. And that's a reference to what I think is probably the most common symptom of the onset of diabetes, frequent passing of water as the kidneys are going into overdrive to clear all this excess sugar that's in the blood. By the 19th century, it was known that the pancreas was central to diabetes. Two researchers, Minkowski and Mering, noticed that when you surgically removed the pancreas from a dog, the poor animal became diabetic. And so researchers began to speculate that maybe the pancreas produces some hormone that controls blood sugar levels. And so the hunt was on to find that hormone. The person who is credited with having found it, Canadian scientist Fred Banting. So in the summer of 1921, Banting and a younger colleague, Charles Best, who was a final year honours student, they'd been removing the pancreas from a dog to make the animal diabetic, and then they'd been making pancreatic extracts and injecting those into the diabetic dogs to see whether that would bring down their blood sugar levels. And then, of course, the time came to test this on a human patient. So January the 11th, 1922, young Leonard Thompson had been brought into Toronto General Hospital. He was 14 years old. He'd been diagnosed with type 1 diabetes a few years earlier, and when his father brought him into Toronto General Hospital, he was pretty much at death's door from diabetes, because prior to the discovery of insulin, a diagnosis of type 1 diabetes was pretty much a death sentence. There was nothing really that could be done for the patient other than put you on a starvation diet to basically delay the inevitable. So January the 11th, 1922, Leonard was injected with some of Banting and Best's extract.
Was that from a dog, Kirsten?
No, it would have been prepared from, by that time, they were making the preparations from bovine pancreas.
So they realised that you could go to another animal and the
Yes,
analogous organ would work. And
Yeah.
so it was a reasonable step to then say, well, let's take this because it's a bigger animal, big pancreas, lots available, and try injecting that.
That first injection on January the 11th was actually not considered to be a clinical success. And the reason was, yeah, sure, Leonard Thompson's blood sugar levels fell, but he was still producing ketones in his urine. So these are toxic compounds that are produced in diabetic patients. But the most serious result of all was that Leonard had suffered an adverse reaction. 2 weeks later, January the 23rd, 1922, Leonard was injected for a second time, and this time it was a success. His blood sugars dropped. There was no toxic adverse reaction.
And how did they achieve the improvement? Did they filter it or clean it up in some way?
Well, what had changed was that second batch of preparation hadn't actually been made by Banting and Best. It had been made by their colleague, James Collip. And what he'd been able to do was work out exactly how you could use alcohol to clean up the pancreatic preparation, to remove those impurities that were causing the toxic reactions.
Did he continue to receive these things? Because there have been these sad stories in the history of science and medicine where people invent amazing remedies. And I'm thinking, of course, of Fleming and Florey's penicillins, where people's lives were initially saved, but they couldn't sustain the production and people then died because they couldn't keep treating them. What happened here? Was the story a happy ending?
Well, Leonard, I think, continues to be treated. I mean, he died very young. In the folklore, he died in a motorbike accident. That's not actually true. I think he died from a pneumonic infection in the end. But what happened with insulin was very quickly word got out about this discovery. I mean, the thing is, Banting and Best and the Canadian researchers had the media on this. They had two key factors. They had the media on their side, the newspapers, and they also had industrial clout. Because, of course, it's one thing to make a discovery like this at the lab bench, but to get it scaled up, to get it purified, to get it into patients, you need industrial backing, and they had that in the form of Eli Lilly. So very quickly, insulin's an interesting example really in the history of medicine, because by early 1922, this stuff was being put into patients in clinical trials. The problem was production was the rate limiting step. And so, there were stories about patients coming and camping out in order to try and get hold of this stuff. And the issue really was how do we make enough of this stuff, and how do we make it fast enough to start getting it into patients? And the other issue as well was, I think the clinicians at the time were concerned about the media trumpeting this as a miracle cure for diabetes, because the clinicians at the time knew it's nothing of the sort. What it does is it transforms what would be an otherwise fatal condition into a long-term chronic one that can be managed. There was a very eminent American diabetes specialist at the time, Dr. Elliot Jocelyn. He was concerned about patients suffering depression if their expectations were ramped up beyond what could realistically be expected.
This is the perfect opportunity to introduce the other person we have here today, who's Charlotte Borton. And she's a diabetes and endocrinology researcher at the University of Cambridge. And she's been part of a team who, in the past, have come up with the organ that you've been referring to, the pancreas, an artificial form of that, so that we can try to treat diabetes better. And Charlotte, you better tell us what was in your mind. I mean, how does this work?
Thank you. So an artificial pancreas is actually three bits of sort of hardware. So unlike the pancreas, which sits in the body, all the bits of hardware are on the body or nearby. So it's all external, and it comprises a glucose sensor, which measures the glucose levels in the fluid surrounding the cells in real time, an insulin pump, which delivers insulin just under the skin. Both of these components are commonly used by people with type 1 diabetes. And the clever part of an artificial pancreas or a closed loop system is an algorithm, which in the system that's been developed at the University of Cambridge is hosted as an app on a mobile phone. And that receives information from the glucose sensor and calculates the right amount of insulin to be delivered by the pump. And it does this automatically, adjusting the levels every sort of 10 to 12 minutes, and allows the person with diabetes to continue without having to do those adjustments manually.
Apart from superior convenience, not having to prick your finger, test your blood and so on, is it better to have a system continuously doing these measurements and topping up insulin? Is that because it's more similar to what your body would do itself? Does that translate into better health?
Yeah, exactly. So it allows you to get more what we call physiological replacement of insulin. And we've shown, and other groups internationally as well, that closed loop systems allow people to get better glucose control than with a pump on its own or injections, and also can reduce the risk of dangerous hypoglycemia as well. So there's both biological benefits, but also psychological and burden benefits for somebody living with type 1 diabetes.
Is this the only show in town, or are you working on version 2.0, which doesn't have any external features, or how are you going to take this forward?
So at the moment, the systems that are commercially available to people with type 1 diabetes still require people to count their carbohydrates and manually tell the insulin pump how much they're eating and therefore how much insulin to deliver. So with newer ultra rapid insulins that have been developed, we're seeing at the moment whether those are quick enough to get rid of the need for people to interact with it. So actually people could literally just wear the devices and forget about it until the devices need changing. So that would truly reduce the burden of type 1 diabetes management. There are also lots of other areas of research within this, including smart insulins, which are designed to turn on when they're needed, when glucose levels are high, and turn off when they're not. I think these are quite far behind where we are with diabetes technologies such as closed loop, but I think these are certainly something to look out for in the future.
I wonder what Leonard would have made of this 100 years ago, Kirsten.
I think he would have been delighted. I just wanted to say to Charlotte, so I actually have type 1 diabetes myself. In fact, as you've been speaking there, I've just been doing a quick blood glucose check. I'm fitted with one of these cyborg devices. That's how the kids like to think of it, as dad being a cyborg, one of these implants. So I just swipe my phone on it. But I thought your work there on the artificial pancreas is so exciting. So as somebody with type 1 diabetes, I'm really going to be watching this with eager anticipation. As somebody who's just written a book about the history of insulin, I'm thinking, oh my goodness, I better get in touch with my publishers and beg them to publish a second edition so I can write another chapter to cover the research you've been doing. But no, just wanted to say thanks very much for all you're doing there, and I look forward to it. But got big hopes, fingers crossed.
Thank you very much, Kirsten. And thanks also, Charlotte. That's Charlotte Borton and Kirsten Hall. And you can get Kirsten's book that's out from the 13th of January, appropriately enough, for the anniversary and the centenary. It's called Insulin, the Crooked Timber, a history from thick brown muck to Wall Street gold. Now, would you call yourself green-fingered? While many of us dabble with a bit of gardening or tend to the odd houseplant, we often don't consider how plants behave. Well, the new BBC documentary, The Green Planet, presented by Sir David Attenborough, is looking at just that.
The vine tightens its grip and begins to haul itself upwards. But it's now overtaken by the forest's fastest growing tree, a young balsa.
I can tell already it's going to be a hit. Mike Gunton's the executive producer of The Green Planet. He's here to give us an insight into the fascinating plant species that we live alongside on our planet, and also the fascinating stories behind the filming of this new series. Mike, how do you go about putting all this together? Because presumably before you put a camera in front of a plant or even a script in front of Sir David Attenborough, there must be massive amounts of work that go on behind the scenes to work out what you're actually going to document.
Absolutely right. I mean, it's a combination of both two things. One is the research to find the stories, but in this particular case, with trying to take an audience into the world of plants, which of course live in this kind of parallel universe in a different time frame, we also had to spend an enormous amount of time thinking about how we're going to do that technically. Because although, time lapse is a way of doing that by seeing plants in their sort of time frame, we've done time lapse for many years to try and get something that feels more like a planet Earth, which is what we were trying to do, a planet Earth for plants, if you like, meant we had to think of some new technology to allow us to do that, to immerse the audience in this extraordinary world. So yes, probably about a year of scientific research to find the stories, and about the same amount of time going alongside trying to find and develop new pieces of tech to allow the audience to come on this extraordinary journey.
There's about 400,000 plant species on Earth. I learned that from a plant scientist who's actually trying to document every cell in every plant species on Earth. And she said it's a big project. Now I understand why. But how did you choose the plants you were going to look at? So did you have some kind of insight into what sort of stories you were going to tell? And what was the new technology that you had to invent?
Funnily enough, in the same way as you go about choosing stories for a planet Earth, where it's all about the animals, you're of course looking for stories that the audience can connect with, that are dramatic, that tell you something remarkable about the lives of these living things. So it was trying to find stories where there was an intrinsic drama, and often it comes with conflict. Conflict in the animal world is paralleled in the plant world. Plants competing with each other for light or for nutrients or for mates or for sex. And so we looked for those kind of stories, and also stories whereby the plants themselves were very active. So when we put our time-lapse cameras on them and sort of speed up time so you enter their world, you see this dynamism in action. And what the technology was trying to do was, rather than just reveal this in a kind of tableau, just as locked off shot, the idea was the camera would move through the world as if you were following animals, and take different perspectives. So if you had, for example, two plants competing with each other or fighting with each other, or one attacking the other, rather than just seeing it in one shot, the camera can take the perspective of the attacker. It can take the perspective of the attackee, the one that's being subjected to the attack, and then also see it from a wider perspective, and sometimes even see it from effectively onlookers' perspective of some of the other plants. So the way you do that, and it's all a bit secret, the technology, but it's using robotic motion control cameras. So effectively the cameras remember where they were throughout the playing out of the story. So they can take time-lapse image one of plant A, and then they move around to a different position to take a shot of plant B, but then they go back to where they were to position plant A to take the next shot. And as you can imagine, the engineering challenge of that to be so precise was immense. But anyway, we've done it. And when you see it, it almost feels like an unreal, almost a magical perspective, because you, the viewer, and the camera are moving in our time, but what's going on inside the frame, which is the plant world, is going on in their time, in time lapse. It's quite a sort of interesting mind game when you watch it.
Well, you mentioned time. Here's a clip of a plant that you documented that took a very long time to open.
After about 5 years, the bud finally opens into a monstrous flower. It now has only a day or so in which to be pollinated before it starts to wither. Its petals are the colour of blood.
Did you really spend 5 years on that?
No, the backstory of that is 5 years. We filmed the bud growing over a considerable length of time, but the bit that we spent most of the time is watching the flower open and this remarkable seduction that goes on where the flower attracts carrion flies effectively because
it smells like death, doesn't it? It smells
exactly
gross. Apparently, it's one of the worst smells you can encounter.
And you can tell David's enjoying himself with the relish with which he tells all that, because there is a sort of theatre about this, because they're unseeable other than through the camera and through our technology. And so when you do see it, it is like going to the theatre and seeing some magic show being performed, but the difference being it's real and it's true, and it's all the more remarkable for that. That's one of my favourite stories. That it's the biggest flower in the world. It's a remarkable thing.
You were commenting on a brush with cacti as well, because that's one of the other things you cover in the series.
One of the things about this series that has been fun for me as a filmmaker, I've been doing this for about 30 years and started way back in the late 80s with my first film with David Attenborough when I was in my 20s. And the fun of that was taking David all over the world and doing these remarkable sort of demos where he'd climb into this and climb up that. And of course, he's now in his 90s and it's harder to do that. But he and we were very keen to try and redo that, revisit that in this series. And so we have taken him not all over the world, but to much of the world, and he's got out there and done stuff. And as ever, game for all sorts of remarkable things, including there's this wonderful cactus or extraordinary cactus called a teddy bear choya. It looks like it's called that because in backlight, it looks a bit like a teddy bear's ears because it's all got it slightly looks like it's fur, but those are really nasty spines, very, very powerful defensive spines. David, being David, said, well, I can demonstrate that by shoving my hand into one of these things and showing how vicious they are. But of course, he has to do it with a welding glove with a Kevlar lining to it, which we thought nothing could get through. And so he gamely shoves his hand into this thing to show you. And then, pulls his hand back because these spines are so vicious. They even manage to go through this thing. And being the trooper he is, he carries on and delivers his story about how effective it is.
One of the things which has increasingly come up in the mix in recent years has been the conflict between us as humans, our use of the planet, our use of the world, and the animal species that you've been documenting. Are you also showing those conflicts here in the Green Planet?
Absolutely. I mean, there's two things that I think we want to get out of this. One is that it is a wonderful, extraordinary, magical world full of fascinating science and full of fascinating biology, but also how important plants are and how we're all a bit plant blind. We take them for granted. They'll do a lot of the heavy lifting for us in trying to recover, both in terms of biodiversity, but also in terms of carbon capture and all those kind of things. And they'll do it without us having to do much. Leave them alone and they'll do it. And part of the story really is to say, not only be amazed and wonder in these things, but treasure them and realize that just because they don't run around doesn't mean they're not important, and also that they're not vulnerable. And lose them at our peril. They will be, if we don't look after them, that will be a fundamental problem for us in the future. So that message, I tell it in stories, but that message I hopefully will come over loud and clear.
And before you go, stand-up moment for viewers to look out for?
It's like trying to choose your favorite child, isn't it? I mean, I think I've done this for many 30 years, and I think I don't think I've ever been more astounded by the stories that we've discovered and told. I think in the opening program, when you see that moment when the tree falls and suddenly the forest floor, which has been quiet for tens of years, bursts into life, and all these plants start doing their thing to try and race to the light using different technologies. And you see it in this, it's almost like being godlike, looking down on a battlefield, seeing all these different things fighting over and trying to win. I think that's pretty remarkable. And that sort of dynamism is, I think, throughout the series. And I think you get a sense of these are extraordinary living things that are doing stuff just out of our sensory world, but nevertheless still utterly remarkable.
Thank you very much to Mike Gunton, who makes a very powerful case for why we should all tune in and watch The Green Planet, which is Sir David Attenborough's new BBC documentary series that starts on Sunday, 7 p.m. on BBC One. You can also find that on BBC iPlayer. Now, from plants to what is lurking in the plant undergrowth, and the surprising finding that hedgehogs might be the origin of one form of the antibiotic-resistant bacterial superbug MRSA, which stands for methicillin-resistant Staphylococcus aureus. New research, which has been published in the journal Nature this week, has found that a microbial war going on the skins of our prickly hedgehog friends is probably where MRSA came from in the first place. And Cambridge University vet and immunologist Mark Holmes, who's one of the team who made the discovery, how did you link MRSA and hedgehogs in the first place? It's not an intuitive leap.
No, it isn't. About 10 years ago, we discovered this new strain of MRSA in dairy cows. And at the time, we assumed that antibiotic use in treating cows might have selected for this. But we looked more widely to see where this type of MRSA was. And we found quite a bit of it in wildlife, in fact, scattered throughout Europe. And then we sort of almost stumbled upon the fact that hedgehogs seem to have lots of this MRSA. And we started off with a survey in Sweden and in Denmark, and it turns out that around about 50 or 60% of hedgehogs have this MRSA.
Well, was someone just swabbing hedgehogs for the fun of it?
Yes,
I mean, how did this come to light? It doesn't seem an intuitive thing to do.
No, I mean, there's always an aspect, I think, of most scientists of being a bit curious and a bit stamp collectory. So once you've found, when we found it in farm animals, we obviously, our initial thought was, where are the farm animals getting MRSA? The obvious place they get it from is from people, but we still swab wildlife to see, because actually one of the other aspects of our research is what makes a bacteria particularly want to live on a particular host, particularly something like Staphylococcus aureus. We find it in many species of animals, but we don't necessarily find the same strains on the same species.
Why have they got it at all?
About 60 years ago, researchers in New Zealand had made an observation that there's a particular fungus, a skin disease on hedgehogs that they got. And when you got hedgehogs with these skin disease, this fungal skin disease, you tended to be able to detect penicillin-resistant bacteria. So when we made our observation and read those papers in the dark history of microbiology, we put two and two together and wondered if this is what was selecting for the MRSA on hedgehogs. And there followed a lot of work where we sampled lots of hedgehogs, we looked for fungus on hedgehogs, we sampled the MRSAs, we sequenced those bacteria, and are able to show pretty well, without much doubt, that the hedgehog MRSAs firstly existed all that time ago, and the ones we find in people are closely related to the ones we see in the hedgehogs, and they are similarly geographically distributed. So particularly in one of our sample sets is from Denmark. And there on one of the islands, all the people and all the hedgehogs have one sort of strain of the MRSA. And on another island in a different part of Denmark, again, the hedgehogs and the people share very similar strains of the MRSA, but the two geographical strains are clearly distinguishable.
To make this clear then, some hedgehogs get fungal skin infections, and that fungus is doing something that enriches for the presence of the Staphylococcus, and specifically the Staphylococcus that happens to be resistant to, you say from New Zealand, penicillin, but that's going to include methicillin, isn't it? MRSA. So it's the presence of the fungus carried by the hedgehog that then selects for resistant bacteria on those hedgehogs.
Yes, and it won't come as a surprise to many listeners who'll remember that Alexander Fleming discovered penicillin because he had a fungus growing on a plate of bacteria. So we've known for a long time that fungi are a good source of antibiotics, things that kill the bacteria. And the fungus produces this antibiotic in order to outcompete for the resources, the food resources on the skin of the hedgehog.
And the genetic know-how for how their particular MRSA does what it does, that's then shared with strains that then cause superbug infections in hospital. That's how we basically have got those things. They already existed, but our use of antibiotic in hospital has enriched the genetic sharing of the know-how among strains that infect humans.
Yes, I mean, it's probably true almost every type of antibiotic resistance that actually evolved in nature. It, was selected a long time ago. So these resistance genes are scattered about throughout nature and throughout the environment. However, what we do as people is we use vastly more antibiotic than ever a fungus secretes. All these antibiotics, and many of these antibiotics end up in the environment. And what's happening with human use of antibiotics is that we've upped the ante as far as selection pressure. So the amount of antibiotics that bugs are exposed to is much more than it would be in nature. They come across it more frequently at higher concentrations because of the medical and veterinary use of antibiotics.
Mark, thank you very much indeed for sharing that discovery with us. That's Mark Holmes. He just published that in the journal Nature. And that's where we have to leave it for this week. Thanks very much for listening, and thank you also to the people who contributed this week. They were, in no particular order, Luke O'Neill, Christina Pagel, Zoe Kleiman, Chris Barrow, Matt Bothwell, Kirsten Hall, Charlotte Borton, Mike Gunton, and Mark Holmes. Julia Ravey put the programme together, and do tune in next week when we'll be asking, have we unknowingly found ourselves amidst the future of robotics in 2022? We're exploring the unusual ways that robots are assisting us both in society and at large, from the deep ocean right through to the operating theatre. The Naked Scientist comes to you from the Institute for Continuing Education at the University of Cambridge. It's supported by Rolls-Royce. I'm Chris Smith, and from all of us here at The Naked Scientist, thanks for listening and goodbye.